Hello everyone, this is Dr. Ian. For today, we're going to be working on properties of parallel lines cut by a transversal. One of the skills that we need to learn in learning or working with problems in geometry is writing two-column proofs, and to be able to gain the skills that we need to be able to write proofs such as the two-column proofs, we need to be familiar with the theorems, properties, postulates, and corollaries that we use in geometry, and that's what we're going to be working on today in our lesson today. So first, let's work with alternate interior angle, converse. And when we say converse in geometry, it means that if we have a conditional statement P then Q, its converse would be Q then P. So in this particular theorem, if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So notice that we have words like alternate and interior, and we're going to use that to describe and, of course, identify angles that are congruent. So in this diagram, we are given parallel lines L and M cut by a transversal, and since we are seeing 4 and 6 to be alternating, and at the same time, inside our parallel lines, we know that they are congruent with this particular reasoning that they are alternate interior angles in geometry. So we know in conclusion that the measurement of angle 4 and 6 are congruent, and the measurement of angle 3 and 5 are also congruent. So this is our first theorem, and we're going to use this to be able to identify the measures of these four angles that we have in this diagram. So our figure, we are given a parallel line or parallel lines cut by a transversal, and we know that the measurement of angle 3 is 55 degrees. So our measures here would be equal to 55 degrees, and from here, all we need is one angle measure for this set of measurements or angles cut by a transversal, and we'll be able to figure out the measures of A, B, C, D using our theorem. So let's start with angle 5, and this angle 5 right here, it resembles angles inside the parallel lines, and they are alternating, so we know that they are congruent. So angle 5 is equal to 55 degrees, with the reason that they are alternate interior angles. And this is how we practice, how we use the theorems in geometry, so that we'll be able to practice and be familiar with these theorems. So when we start working with our two-column proofs, we'll be able to understand it better. And with 7, this measures right here, in reference to measurement of angle 5, we know that they are vertical. And when we have vertical angles, we know that they are congruent. So the measure of angle 7 will be 55 degrees as well. And with measurement of angle 4, we can see that we can reference it to 55 degrees, or the measurement of angle 3, and it forms a straight line right here, and we know that straight line is equal to 180 degrees, and if they are supplementary angles, they equal to 180 degrees. So all we need to do is to subtract 180 or subtract 55 degrees from 180, and its difference is equal to 125 degrees. So that means the measurement of angle 4 is equal to 125 degrees. And the reason why we're able to perform this mathematical equation is because this is also a linear pair. So that means using this theorem associated with this angle right here, we'll be able to show that the measurement of angle 4 is also 125 degrees, or equal to 125 degrees. And now that I have shown the measurement of angle 2 by accident, we already know that angle 2 is 125, and that is because they are vertical angles. So this is how our thought process should be like when we are starting to work with theorems in geometry in answering problems similar to this one in preparation to our lesson on writing two-column proofs. So let's learn or review on some of the theorems that we use with parallel lines cut by transversal. And the next theorem would be corresponding angles converse. And in this converse, this theorem states that if two parallel lines are cut by a transversal, then corresponding angles are congruent. And what are the corresponding angles in parallel lines cut by a transversal? This is a diagram that will help us identify those corresponding angles. So if we have L and M, that wherein both of them are parallel to each other, cut by a transversal, we know that 1 and 5, they are corresponding, and notice that the measurement of angle 1 is obtuse angle, and the measurement of angle 5 is also an obtuse angle, and since they are parallel lines cut by a transversal, we know that they are congruent, or with the same measurement. And we have angle 3 and angle 7, obtuse in a parallel line, so they have the same measurement because they are congruent. And the measurement of angle 2 and 6, notice that they are both acute angles and they are corresponding, so their measurement are also congruent. And the reason why we are saying that they are congruent, it's because their relationship is that they are in a parallel lines cut by a transversal. So in conclusion, the measurement of angle 1 and 5 are congruent, the measurement of 2 and 6 are congruent, 3 and 7 are congruent, and 4 and 8 are congruent. So this is the corresponding angles converse, which we're going to be using later in identifying the properties or theorems we're using as to how we're able to figure out the measurement of certain angles. Let's continue with side-side interior angles converse, also known as the consecutive angles in our parallel lines cut by a transversal. So in this theorem, it states that if two parallel lines are cut by a transversal, the same side interior angles are supplementary. So the operative words that we're using here, same side and interior in a parallel lines, and when that happens, they are supplementary, and we know that supplementary, it means that the sum of the angles is equal to 180 degrees. So in a more visual representation of this theorem, we have parallel lines cut by a transversal, and we know that 4 and 6, they are alternating, and they are inside our parallel lines, and when that happens, they are supplementary, which means their measures, when you add them up, is equal to 180 degrees. Same goes with 3 and 5. So their measurements would equal to 180 degrees because they are supplementary. And also, notice the type of angles formed by 3 and 4. This is an acute angle and this is an obtuse angle. So that would be another clue or reference idea that you can use to be able to identify the same side interior angles in a parallel lines cut by a transversal. So, in conclusion, the measurement of angle 4 added to the measurement of 5 is 180, and measurement of angle 3 added to angle 6 is equal to 180 degrees. And the last theorem that we're going to be using today would be the alternate exterior angles converse, wherein if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. And the words that we are going to watch out for would be alternate and exterior. So in this parallel lines, our alternating angles and should be exterior or outside our parallel lines. That's how my brain visualize exterior angles cut by a transversal. It's outside the parallel lines, and interior angles cut by a transversal would be angles inside the parallel lines. So here we are seeing 1 and 7 as exterior, and they're also alternating, so that means that they are congruent and they have the same measurement. And notice that angle 1 and angle 7 are both obtuse angle. So in that way, we'll be able to see a better understanding or connection on the definition of the alternate exterior angles. And in this case, we know that 1 and 7 are congruent and 2 and 8 are also congruent. And now that we have covered the theorems in parallel lines cut by a transversal, let's use them in identifying the angle measurement of all of these angles, knowing that we have measurement of angle 4 to be 42 degrees. So if this is 42 degrees, with all the theorems that we have learned from the previous slides, we'll be able to not only identify the angles or find the measure of the angles, but also give the reasoning how we got that answer. So we'll start with the easy one, which is the measurement of angle 2. And it's easy because we are all too familiar with the vertical angles, and we know that 4 and 2 are vertical, so they are congruent. So our reason why we know that angle 2 is 42 degrees because they are vertical angles. And for the measurement of angle 6, in measurement of angle 6, we are seeing that our reference angle here could be angle 4 because it's given, and we are seeing that they are inside the parallel lines and they are alternating, and when that happens, they are alternate interior angles, and we know that they are congruent from our theorem. So we know that 6 is 42 degrees because it is alternating an interior with angle 4. So that can be our reason as to how we got 42 degrees for the measurement of angle 6. And for the measurement of angle 8, easy peasy because they are vertical to 6, so it's also 42 degrees. So we can now write 42 angles for measurement of 8 because they are vertical angle. And for the measurement of 7, we can use the measurement of 6 and the measurement of 8 because we already got that from the previous angles. And we can say that they are supplementary because they are neighbors and they form a straight line. And in this particular problem, just subtract 42 degrees from 180 degrees and it's equal to 138 degrees. And the reason for that is we can use the linear pair theorem to justify how we got 138 for the measurement of angle 7. And for measurement of angle 5, again, we can use linear pair with 42, or we can also use vertical angles for 7. So we can say that angle 5 is 138 degrees because it's vertical to angle 7. And for the measurement of angle 3, just like what happened to the measurement of angle 5 and 7, we are seeing linear pairs right here that we can use. So they are equal to 180 degrees. So 180 minus 42 degrees is 138. We are now seeing linear pair, or we can also reference it to the alternate interior angles because we know that the measurement of angle 5 is 138 degrees and they are inside the parallel lines and they are alternating. So we can also use the alternate interior angles for the measurement of angle 3. And for the last angle, measurement of angle 1, we know that the measurement of 1 is 138 degrees, and we can use either linear pair theorem for angle 2, or we can also use this theorem right here. Alternate exterior angles are corresponding. That's why it's also 138 degrees. But for this one, I used the vertical angle theorem, or the definition of vertical angles, to show why angle 1 is equal to 138 degrees. And this is how we completed our angle measures and the reason how we got those angles. Now, let's answer this a little more challenging problem wherein we need to solve for the values of x given this figure. And in this figure, we have L parallel to M cut by a transversal. And from here, we'll be using geometry and algebra to solve this problem. And when problem like this happens, we know that we're going to use geometry first to solve this problem. And how will geometry help us in solving this algebra problem? By formulating the equations that we will be using to solve for x. And I am seeing that the measurement of angle 3 is equal to 105 degrees. And I know that because we are using an alternate exterior angle theorem. And we know that with this, they are congruent because they are alternate exterior angles in this relationship of parallel lines. So we can say that since the measurement of angle 3 is equal to 105 degrees, we can now use another theorem to equate x plus 30 degrees plus the measurement of angle 3 to be equal to 180 degrees, because we know that they are linear pairs. And when this happens, we now have our equation that we can use so we can solve for the values of x. Because if we have x plus 30 degrees and we know that the measurement of angle 3 is equal to 105 degrees, now we can use algebra to find the value of x. And to be able to do that, all we need to do is to add 30 and 105 and subtract it from 180, and we'll be able to solve our problem. So, recap, I got the measurement of 103 equal to 105 because I know that they are alternate exterior angles. And from here, I was able to equate x plus 30 plus measurement of 3 equal to 180 degrees because they are linear pairs. And from here, I can now use algebra to solve for the values of x. And when I add 30 and 105, I'll have x plus 135 degrees equal to 180 degrees. Subtract 135 degrees on both sides. And we'll have x by itself equal to 45 degrees. So now that we know what x is, we're now able to solve this problem using geometry and algebra, and that is the beauty of understanding and knowing our theorems in geometry, so that it would help us move forward in answering challenging problems like this, wherein we need to formulate our own equation based on the theorems associated in this figure, so that we'll be able to use our algebra skill to solve for the values of x. And for your Numberbender challenge of the day, you are given two parallel lines cut by a transversal, and we know that angle 3 is 45 degrees, and your task is to find the measure of angle 7. And understanding the theorems associated with the parallel lines, I'm pretty sure that you'll be able to answer this easily. So comment it down below and give me the reasoning how you got the measurement of angle 7 from this problem. And this is Dr. E, and this is our lesson on properties and theorems on parallel lines cut by a transversal. And again, this is in preparation for us to be able to understand two-column proofs better, and for us to execute and write our own two-column proofs, knowing and understanding the theorems that we are using in geometry. See you again next time. Bye!